Learning objectives. In this chapter, the users would learn the following aspects of component stuffing, mounting on PCBs, automatic soldering, application of the solder resist, flux application, solder application, automatic removal of solder bridges, hot air jet knives, types of circuit boards, special considerations for SMT boards. Automatic soldering. It is a process of using and developing printed circuit board by using various kinds of automatic machines for mass production. This approach of design and development is chosen to meet the developing and emerging demands of the modern electronic industry. It is a mass-scale soldering process in which the electronic components are soldered to a printed circuit board for the purpose of developing an electronic assembly. In this process, a large quantity of molten solder, which is contained in a tank, attaches metal components to the PCB. Further, the components are automatically either inserted or placed on the PCB. At the same time, the loaded PCB is allowed to pass through the automatic flow of solder. Further, soldering flow or spray wets the unmasked metallic areas of the PCB. Here, a protective coating acts in preventing the solder from entering the electronic connection. By this way, a reliable separation is made between mechanical and electrical connections. The advantage of this process is to design and develop faster soldering of components than the manual ones. Here it is important to note that though there are many types of automatic soldering machines, the basic operation of soldering the components remains the same. Application of the solder resist. Solder resist is a type of sealing wax which has thin lacquer-like layer of polymer. It is applied on the copper traces of a printed circuit board for component safety. The main purpose of this application is to protect against oxidation of components. In addition, it is also used to prevent the formation of solder bridges between closely spaced solder pads. Solder resist offers a professional finish to the PCB by not allowing the two conductors to join and create a fear of electric short circuits. It is generally not used in manual soldering process, but it is essential to apply during the automatic soldering process for the large-scale production of PCBs. Traditionally, it is green, but in the present day, it is available in multiple colors. Flux applications. The purpose of flux is to smoothen the progress of the soldering. One of the difficulties to a successful solder joint is uncleanness at the position of the joint, for example, dirt, oil, etc. The impurities can be removed by mechanical cleaning, but the prominent temperatures required to dissolve the filler metal encourages the workpiece to reoxidize. This effect is accelerated as the soldering temperatures increase and can completely prevent the solder from joining to the workpiece. One of the most basic and prominent forms of flux was charcoal, which performs as a reducing agent and helps prevent oxidation during the soldering process. There is some more valuable information on flux. Some fluxes go beyond the simple prevention of oxidation and also provide some form of chemical cleaning. The most frequent type of flux used was rosin-based, which is used in electronics. Apart from electronics, the plumbing and automotive applications typically use an acid-based like muriatic acid flux, which provides cleaning of the joint. Flux performance needs to be carefully assessed or evaluated. A very mild no-clean flux might be perfectly suitable for the production equipment, but not give sufficient performance for a poorly controlled hand soldering operation. Soldering applications. Soldering is a process in which two or more metal items are connected together by melting and flowing a filler metal into the joint. Soldering is necessary when the electronics components are needed to be connected to the power circuit boards. Most electrical goods these days include components that have been soldered through an automatic or factory process. Soldering operations can be performed with hand tools, one joint at a time, on a production field. The part-time radio or model railway enthusiasts rely on their soldering skills and knowledge. Let's gain some more knowledge on soldering applications. Hand soldering is naturally performed with a soldering iron, soldering gun or a torch, or occasionally a hot air pencil. Electricians, plumbers, and a wide range of tradesmen will regularly have to solder during their courses of work. Plumbers construct everlasting but reversible connections between copper pipes in domestic heating systems. The comparatively low temperatures of hand soldering differentiates it from factory or automated sheet metal soldering, brazing, welding, and other methods of industrial bonding, which require load-bearing connections. Automatic removal of solder bridge using hot air jet knives. A liquid flux using water instead of an unstable organic compound as a liquid carrier is used in a wave soldering process. Undesirable formation of solder balls, solder bridges, and solder webbing is prevented by using an air knife to direct a vigorous jet of gas at the dielectric substrate in the preheating section. A solder bridge is an unintended electrical connection between two conductors by means of a small blob of solder. Convective heating methods include the use of a hot air jet for melting solder, and such methods are presently being used for desoldering operations. Although it may be possible to perform a debridging operation using an individual hot air jet, it is difficult to control such an air jet and to limit the area which is heated. This makes it difficult to control the amount of solder which is removed, especially at a solder joint, and makes it particularly difficult to use such a process with 8 middle pitch or smaller leads. Types of circuit board. There are 4 types of circuit board which can be used in different types of industry for the electricity purpose. The types of circuit board are breadboards, perf board, etched PCB, strip board. Breadboard. Breadboards are enormous for quickly prototyping a circuit and permit you to simply reuse the components for other projects. But they are not as firm and don't feel as complete as the same circuit on perf board. Etched PCB. Etched PCBs can take time and go improper if you make them at home, or cost money and time spent waiting to have them manufactured, but might deeply lessen your time spent in assembling the circuit. All you need to do is drop the individual components in place. Perf board. Perf board is conceivably the most accepted board type for makers and hobbyists. Most perf boards are pad per hole, with one conductive pad per hole, which are spaced on a 0.1-inch grid. Strip board. Strip board is a kind of perf board with parallel strips of copper in place of individual pads, so the strips create a conductive connection between the elements without the need for additional wire. You can generate breaks in the copper strips in order to certify the circuit's components don't short out. So a circuit planned out in advance can be built on strip board with little to no solder trace between components. Special consideration for SMT boards. There are different kinds of consideration for surface mount technologies. Those are PCB consideration, solder alloy, flux consideration, print process considerations, reflow process considerations. PCB consideration. The consideration of surface finish is the important PCB consideration. The surface finish is determined based on wetting, storage, planarity, and cost issues. Amongst the several PCB surface finish, organic solderability preservatives and metallic surface finishes are mostly available in the industry. Solder alloy. A wide range of solder paste alloys are available in the industry. The tin, silver, copper family of solder alloys is most commonly used for SMT manufacturing. The eutectic and lead-free solder alloy selected must be non-hazardous, mechanically reliable, thermal fatigue resistant, have good wetting and relatively low melting temperature, and must be compatible with a variety of lead-bearing and lead-free surface coatings. Flux consideration. When selecting flux chemistry suitable for tin lead-free processing, you must consider the flux activation temperature, activity level, compatibility with chosen lead-free alloy, and reliability properties such as surface insulation resistance, SIR, and electromigration. Print process consideration. The lead-free process requires special handling. The development of printing process and paste handling need to be considered while handling. The shelf life and storage conditions may be different from eutectic solder paste. To avoid such issues, the method of printing process and paste handling need to be followed accurately. Reflow process consideration. For lead-free soldering, the most important factor to consider is the characterization and optimization of the reflow process. The reflow process window for conventional soldering is relatively wider than that of lead-free soldering. Soldering technique. PCB design is important not only for the evaluation of circuit ideas before incorporating them into chip, but also the soldering techniques to be employed in production. Soldering tools. There are different soldering tools and techniques which are required to set up PCB. Soldering iron, solder, flux or rosin. Soldering iron. It is used to melt solder and join the component pins to board pads. A cheap soldering pencil may be sufficient, but ideally, temperature-controlled solder station is the best for performance. Solder. Solders are the most common type used for electronic assembly. It is an alloy of tin and lead with a low melting point. Depending on the diameter and metallic and core content, various soldering solutions are available. Thick and thin solders are useful for the connection of power devices and surface mount technology as well. Flux or rosin. It is a substance used for channeling of solder flow and prevent to form oxide. Earlier, rosin was beneficial for this purpose, but flux is much better and very much popular as per today's demand in the market. There are some more tools for soldering. Solder wick, alcohol and cotton swab, hot plate, pliers, knife, multimeter and magnifier. Solder wick. A tool is used to extract solder and desolder components from the board. If large amounts of solder are present, then the tool called as pump is very beneficial. Alcohol. Alcohol is used to clean the rosin and dirt off the PCB. Cotton swab, which is soaked in alcohol, can be used to clean the particular area of the PCB. Hot plate. It is a tool used to seamlessly solder SMT packages and multi-pin chip components to the PCB. Pliers, knife, multimeter and magnifier. Pliers are used to cut, bend the components. Knife is used to strip the wires. Multimeter for the testing of electricity, connectivity. Magnifier is used to inspect the soldering work. Inspection of PCB board. To inspect the PCB board, it's recommended to use a magnifier and a strong light. Search for tombstones. A tombstone is an appearance used to illustrate a particular element which stands straight up or soldered to one pad only. It happens often in construction with two-terminal SMT devices like resistor and capacitors. When the element is in the reflow phase, if any one of the terminal has less solder than the other, the mass and movement of the extra solder becoming dissolvent can pull the element off the opposite pad. Often the part stands straight up, like a tombstone. Search for broken and or lifted traces. Often heat will cause copper traces to lift and or break. With SMT trace, lift is less prevalent because typically there is less mass involved. The SMT components are smaller and closer to the PCB, so the forces they exert on the copper traces are reduced. Look for moving bands of copper, scratches, or small holes. Search for stained and or cracked elements. Burned elements are typically caused from an overcurrent condition. Search for the burn marks, which are brown or black depending on the fault. With SMT, the PCB is often burnt because the element is physically closer to the PCB. But again, before accusing the PCB, take a photo and then clean it thoroughly. Sometimes the burn looks worse than it really is. The only way to find out if there's a real PCB damage is to clean the PCB and re-examine it. Cracked SMT components are often caused by vibration or excessive heating. However, overvoltage conditions in ceramic components is a common cause of cracking. Often cracks in ceramic capacitors are hard to see. If you suspect a crack in a ceramic capacitor, just replace it. With all SMT ceramics, soldering is a serious issue. Thermal shock must be kept to a minimum. Search for broken and or lifted traces. Often heat will cause copper traces to lift and or break. With SMT trace, lift is less prevalent because typically there is less mass involved. The SMT components are smaller and closer to the PCB, so the forces they exert on the copper traces are reduced. Look for moving bands of copper, scratches, or small holes. Search for cold and or cracked solder joints. Inspect the solder joints for cold solder joints, not silver and shiny. This means that the solder cooled and was reheated. The cool solder may stay solid while the new molten solder is added. When molten and solid solder are mixed in a solder joint, it can lead to cracking. With newer lead-free circuit solder, it is often hard to tell a cold joint from a good joint because the cooled lead-free solder has grayed appearance. Precautions. Some precautions need to be taken while developing a PCB with the help of tools. The precautions are: practice makes you ideal, proper order, immobilize elements before soldering, heat the joint, use capillary forces, test connection. Conclusion. In this chapter, the users have covered the following aspects of component stuffing, mounting on PCBs: automatic soldering, application of the solder resist, flux application, solder application, automatic removal of solder bridges, hot air jet knives, types of circuit boards, special considerations for SMT boards.